Now let me give you an example of where I would use the kappa, because we actually have a different rubric that we are using now for which we need to use the kappa. Remember, the R would be used for interval and ratio level measured variables. Here is a critical thinking rubric in which there are 3 capabilities. 1, selecting the relevant, 2, uncovering and addressing the important, and 3, adding insights. And within each of these capabilities, we have a possibility of 0, 1, 2, 3. And these are much more categorical. We're not going to add up for a total score in critical thinking. We're actually looking at, okay, how well does the student in these categories select the relevant? This is about analytical reasoning. In this category, uncovering and addressing the important, how well does the student do? And in adding insights, how well does the student do? There is no totaling of the numbers across the skills. And so in this case, because these are categorical, I'll check the inter-reader reliability with the kappa. So those are some examples in terms of a measuring device, how you would go about, or which one of those measures of reliability you would use. Well, so what? Who cares about reliability? Why is it important? Well, if you recall, measurement is not perfect. Measurement error can crop up when measurement is not perfect. And reliability is one of those determinants of the quality of the measure. So reliability or lack thereof is one of those things that contributes to measurement error. Unreliability leads to error in measurement. It also leads to error in interpreting results and interpreting the associations between the variables. It can crop up in several different scenarios, reliability issues. And that is, it can crop up when there's only one person who is actually doing the observing of the behavior. Whatever you rate today might not be exactly the same way that you would rate a week from now. Or if you're tallying, if you're watching behavior, you're looking for patterns and you're trying to take note, like in field research. It crops up in survey research, and in as much as you want to have good question design. Anytime that you have an unclear question, an individual can answer that question many different ways, but not only can that one individual not understand what the question is asking for, or not understanding what you want in terms of that question. They might answer a question, the same question, differently today or a week from now, but another person, if it's not clearly a question that's clearly defined, would not see the same but measure, would not be understanding of what you're asking for. That's the way reliability problems can crop up in survey research. Researchers try to guard against subjectivity, and when they do that, you can have problems with reliability. A couple of ways to ensure or to strengthen reliability. Use measures that are already established. For instance, we already have ACT scores to measure college aptitude that have gone through rigorous reliability and validity testing. So that would be one good measure of college aptitude. Another way to ensure reliability is to standardize data collection methods. And we'll talk a little bit more about that when we talk about validity. Training and piloting, same thing. Training of survey interviewers, training of readers of student work if you have an assessment or a measuring device like that. Training readers to go through norming sessions so that they understand how to apply a rubric to pieces of student work. Any types of surveys where you can pilot the instrument will help decrease any type of reliability problems you might have. Respondents not interpreting questions the way that you need them to be interpreted. You probably should pilot the survey in order to fix those problems or adjust. And also, one thing that Voigt points out in the textbook is even if authors provide reliability and validity statistics for their data, it's important as a researcher to also compute your own for your data. You should provide as many measures as you possibly can to ensure your readers that you have reliable measures. Reliability measures are consistent, but they're not necessarily always accurate or valid. You can have reliability without validity, and we saw that with the bullseye diagrams. So reliability, for a quality measure, reliability is necessary, but it's not sufficient. For a quality measure, we also need to have validity. We're going to talk about that next. We will have discussion on some of these topics when we're in our face-to-face course.